everyone! Ever wondered why everyone, especially engineers and math students, get stressed out by integrals? Well, today I'm going to break it down in the simplest and most fun way possible. Ready? Let's go! Okay, first, imagine this delicious cheesy pizza. Now tell me, what's its area? Exactly, the area of a circle, which we can calculate easily with a formula, PR2. Simple, right? But what if the shape isn't the perfect circle? Now, picture a big irregular shape of cowhide leather. You want to make a fancy bag out of it, but you don't know if it's big enough. How do we measure its area? By breaking it into pieces we can measure. We might try triangles. But they don't look precise enough. Circles? But they won't fit. Rectangles? Kinda better, but still rough. Wait a second. What if we just make lots of rectangles? Tiny ones. So small, they almost fit every curve. Now we're talking. The more rectangles we use, the closer we get to the real area of the letter. Alright, let's get a little more mathematical. Imagine the letter is lying on a graph. The outline of the letter forms a curve. Now each tiny rectangle heights come from the curve's value. Let's call it our function. Each rectangle has a tiny width. Let's say delta x, and a height equal to the function's value at that point. Multiply the height and the width, and you get the area of that one rectangle. So we add up all these tiny rectangles' area. And as we make delta x smaller and smaller, we're adding more and more rectangles, getting closer and closer to the real area. This is what we call a Riemann sum. Here's where integrals come in. When we take the limit as delta x approaches 0 and the number of the rectangle goes to infinity, we get the integral. It's written like this. This fancy S-shaped symbol means we're adding up infinitely many tiny areas, and dx represents those super tiny widths we're summing over. Okay, so now you know what integrals are. But I haven't answered one question yet. Why do people struggle with integrals so much? Well, it's not because the idea is hard, it's because the function we're integrating can get really complex. Imagine trying to measure the area under a roller coaster path or a reverse curve, or even calculating how much paint you need for a wall with wavy edges. In engineering, physics, and design, functions can get wild. Engineers use integrals for everything, calculating forces on bridges, designing airplane wings, finding the center of mass in a car, even creating realistic shadows in video games. Integrals are everywhere. They're like the secret sauce of the universe's calculation. So next time you hear take the integral, don't panic. Just picture the letter piece and think of all those tiny rectangles adding up to find the area. It's not magic, it's just clever math, and you can do it too. Got question about integrals? Drop them in the comments. Also tell me what topic should we cover next. Don't forget to like and subscribe for more scientific content. See you!